everyone, welcome to the 2.7 Inequality Basics notes. Make sure that you have a pencil, a calculator, and this piece of paper in front of you before you begin. Go ahead and grab that now if you need it. What we're going to be learning about is inequalities. There are three things we're going to talk about: inequality symbols, how to solve inequalities, and how to graph them on a number line. So let's start with the symbols. These two symbols right here, some people call them like the alligator symbols. We're not going to call them that. They're called inequality symbols. If the pointed end is on the left, that is trying to tell you that whatever number is on the left is less than the other one. If it's on the right, it's trying to say that the one that's smaller is on the right, which means the first number is greater than the other one. So pointing end on the left means less than. They both start with L. And if the pointy end is on the right, that's greater than. Then you'll notice the two on the bottom have a little line underneath. Inequalities mean unequal or not equal to. However, the two on the bottom have like half of an equal sign on them. And that means that they can be less than or equal if the pointy end is on the left, greater than or equal if the pointy end is on the right. I need you to know which one is less than and which one is greater than as you're reading problems so that you know what they mean. Over here on the right, we are going to practice finding out which values are solutions to x plus 8 is less than 3. So what I'm going to do is I'm going to zoom in first of all, and I'm going to draw a little line kind of above each of these to separate my work. And here's what I'm going to do. I'm going to start by taking each number and adding 8. Because the number that it's giving me, I'm plugging it in for x right here. So like -7 plus 8 is 1. Is 1 less than 3? Yes, 1 is less than 3. That's a solution. Then I would do -6 plus 8. That's 2. Is 2 less than 3? Yes, that's a solution. -5 plus 8. That's 3. Is 3 less than 3? No. Now that we're halfway, I'm going to pause and say one more time because I don't know if some of you got a little lost. I'm plugging in the number plus 8 because that's what's right here. And then this is where the less than 3 part is coming from. Okay, now I'm going to finish. -4 plus 8 is 4. Is 4 less than 3? No. -3 plus 8 is 5. Is 5 less than 3? Nope, it's bigger than 3. And -2 plus 8 is 6. Is 6 less than 3? Nope, it's bigger than 3. So you'll notice that it stops being true after 5 because that's where it was actually equal to 3. And everything else was more than 3. So 5 is where our number line would stop. And it turns out that this is like a number line where we would put an open circle at -5 because that's where it's equal to 3, but we don't want it to be equal to 3. That's our boundary line. And then we want anything that goes this way because this is where all of our solutions are. And it can include anything less than -5. -8 plus 8 would be 0. That's less than 3. Anything less than that would work. So one of the biggest differences between equations and inequalities, other than the fact that they use different signs, is that they have intervals as their answers, which include many solutions. There are a million numbers less than -5. I could have picked -7, -8, -9, -10, -1 million, -1,000,005, -1,010. any number less than -5. So you're not just going to have one answer anymore, you're going to have a lot of answers. And that's one of the biggest differences between an equation and an inequality. Now, let's go ahead and move on to actually solving some. As far as solving goes, they solve just like an equation, using properties of inequality instead of properties of equality. For example, addition and subtraction. If we had the equation x minus 3 equals 5, you would add 3 to both sides because you need x to be by itself, and we're using opposite operations. So it's kind of like this is my equation line, and I add that 3 here and here to cancel it out. And then I just have the x left on the left side is greater than or equal to. And you have to keep the same symbol. It's not just going to be an equal sign every time this time. It matters which direction it is facing. And then 5 plus 3 is 8. So this is saying x is greater than 8, which means we're going to put 8 on our number line. And since it's got the little line underneath, I'm going to draw a closed circle and shade it towards the direction that is greater than 8. Now, if you need to, put 7, 8, 9. Put those numbers in order, like a number line. We would go towards 9 because 9 is greater than 8. Let's try one more, and then we're going to add something to the top of our page. If I want to get x by itself on the next problem, I've got a plus 4. The opposite of adding 4 is subtracting 4. So you need to do it on both sides. Just make sure you're not drawing your little line through the inequality symbol, or you won't be able to tell what it is anymore. Okay, now all I have left is x is less than -3 minus 4 is -7. So -7 would be the number that goes on my number line. And since there's no or equals to, it just says less than, you would draw an open circle. And I would finish drawing one number on each side of my number line, but be careful because negatives go backwards. So -8 would be on this side, -6 would be on this side. And I would go less than -7, which is towards -8. Because a bigger number that is negative is actually a smaller value. Okay, here's what we're going to add to our notes. If you want to come up here and draw an open circle on the less than and the greater than, and a closed circle on the or equals to ones. That's how you decide. Anyone that says or equal to has to be a closed circle. All right, we've got 2 more to solve up here, and then I've got one last rule to add to inequalities before we're done. Okay, multiplication and division. Remember, if you have x and it looks like it's a fraction over 4, that's x divided by 4. And the opposite of division is multiplication. So I would multiply by 4 on both sides. Cancel that out. And x is less than, and this is where I would have to pull out a calculator and do -3.5 times 4. Go ahead and try that in your calculator really quick. Okay, I got -14. And this is saying x is less than -14. So here I go, I put -14 on my number line. -15 goes on the left. -13 goes on the right. Then, since it's less than but not equal to, we put an open circle. We go less than, which would be towards the left. You can kind of act like it's an arrow. That would be pointing you to the left. That just gets a little tricky later on with some of the other things we're going to talk about. And then the last one on this row is division, because this is 5 times x right here. And the opposite of multiplication is division. So we want to divide by 5 on both sides. It's always going to be division if you don't see the plus or the minus sign in between the number and x. Okay, 5 divided by 5 is 1. So you have 1x is greater than or equal to negative 15 divided by 5, which is negative 3. So negative 3 is going to go on your number line. Negative 4 would be on the left, and negative 2 would be on the right. Closed circle, since it's greater than or equal to. And then negative 2 is greater than negative 3, so we're going to shade that way. Make sure I can tell which way you're going. If you would rather, instead of drawing it like that, you can draw it like this if you want, like an arrow, and show me that way too. Just make sure I can tell which way you went. All right, last rule about inequalities is a special rule about multiplying and dividing. You must flip the symbol, and by symbol I mean the less than or greater than symbol, if you multiply or divide by a negative. So here is what I mean by that. On the next multiplication problem, negative 3 is the number that you need to multiply by. And it means that that negative 4, when I multiply it by negative 3, it's going to turn into positive 12. And anytime that flips signs like that, you need to flip the symbol in between 2. So instead of x less than 12, it's going to turn into x is greater than 12. Okay, so this part right here is the flip. And then 12 would be the number on my number line. 11 and 13 would go on either side. 11, 12, 13. Open circle because it's not or equals to. And now since it's greater than, it's going to go towards the 13. Either like that, or you can draw it like that. Just make sure I can tell which way you're going. That means that 13, 14, 15, 16, 17, 18, 19, 20 are all solutions to this one. And on the next one, division, I need to divide by the negative 5 that's in front of x. Since I'm dividing by a negative, instead of greater than or equal to, it's going to be less than or equal to. And negative 15 divided by negative 5 is 3. So 2, 3, 4. Close circle because it's or equals to. And it's now less than, so it's going to go to the left. So 2, 1, 0, negative 1, negative 2 are all solutions. Okay, here's why inequalities actually matter. We're going to do one word problem together. It says a circuit overloads at 1800 watts of electricity. That means you can't go over 1800. You have to stay less than 1800. So our inequality for this one would be that we are adding to our 1110 watt microwave. 1110. So x is how much you're adding to the 1110 watt circuit, 1110, and we have to stay less than 1800. Because if we equal 1800, that's when it overloads and it starts to, you have to go flip the breaker because the electricity's out now. Okay, if I wanted to solve this, I would subtract the 1110 to the other side, which gives me x is less than 690. Then the next question is asking us, in addition to the microwave, which appliances can you plug in at the same time? So which ones are less than 690? And you can just circle them on the table. The clock radio is less than 690 because it's 50. The blender is 300. But the hot plate and the toaster are 1200 and 800. Those are both bigger than 690. So that would be a no. So just the radio and the blender. Part C says you switch to a microwave that uses 1000 watts. Can you run it in the toaster at the same time? If it can take 1800 and we subtract 1000 instead of the 1110 we did before, that means we have 800 watts left. And the toaster is exactly 800. So it's right there on the borderline, but since it said less but not equal to, I would go with no. Only less than 1800, not less than or equal to. One thing you should know about your assignment is that after it asks you to graph it on the number line, it's going to ask you for 3 solutions. So I'm going to do just one problem with you. I'm going to do the one right here, second row on the left, because there's a -2 in front of x, so I would need to divide by -2 on both sides. -10 divided by -2 is +5. Keep your x, but then because I divided by a negative, I have to flip. So it'll go this way instead. Here's your 5 in the middle. This would go like 4, 5, 6. And since that's got the or equal to line underneath, you would draw a closed circle and shade it in the greater than direction. So 3 solutions could be the number 5 itself, since it's a closed circle. Or you could go with the number 6, or you could go with the number 7. If that circle is open, you can't put it here if it's going to be open, okay? So if that was an open circle 5, I wouldn't be able to put it on that solution list. It can only be a solution if it's in the shaded area, not an open circle.